Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Apologies for shaking camera, keep hitting the table. Anyways, let's get to what is the puzzle? It's a German sum introduction by Senny K. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. And this is a new rule set called the German sum, where a clue outside the grid gives the sum of all adjacent digits with a difference of at least 5 up to and not including the first digit with a difference of 4 or less in that row or column from the direction of the clue. And a digit in the first cell is always included in the sum. So for example, if row 4 is 7, 2, 8, 3, 1, 5, 4, 6, and 9, then the sum would be 20, because it's the digits which are 5 or more away from each other until they are no longer 5 or more away from each other. So 7 is 5 or more away from 2. You're always including the first digit, so 7 is always being included. 2 is 5 or more away from 7, so you include that in the sum. 8 is 5 or more away from 2, so you always include that, and so you include that in the sum. 3 is 5 or more away from 8, so you include that in the sum. 1, however, is not 5 or more away from 3, so therefore we stop the sum there. So therefore the sum is only the first digits, which satisfies, essentially they are the sum of the first digits of all of the digits up until, how do I describe it? They satisfy the this German sum is the sum of all the digits which satisfies the German whisper rule set, or as I like to call it, the whisper 5 rule set, for any adjacent digits previous to it. I think that's the way I would put it, right? So obviously 2 satisfies the whisper 5 rule set for being 5 away from 7. 8 satisfies the rule set. I guess okay, so maybe another way of putting it. The German sum is a sum of all the digits which satisfy the German whisper or the whisper 5 rule set with the digit right before it. So 2 satisfies the whisper 5 rule set with 7, which is right before it. 8 satisfies the whisper 5 rule set with the 2 that's directly before it. 3 satisfies the whisper 5 rule set with 8, because which is directly before it. 1, however, does not. So once you see a digit that does not satisfy the whisper 5/German whisper rule set, then you take the other digits before that and add them all together for the sum. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the max any sum can ever be is 40, because 5 is never going to satisfy the whisper 5 rule set. So, since column 5 has the max sum, this must be a 5 here. And the ends have to be 4 or 9. Sorry, 4 or 6. Because those can only be next to one unique digit for a whisper 5 sum. And because all of these are valid, so this is the only invalid one in column 5, the rest of these must be valid, which means they must be 5 or more away from any digit that's not 5 in front of that is next to it. So therefore, this must be 4 or 6. This is 4 or 6, which is next to 1 and 9. Those 1 and 9s must be next to 3 and 8s. That's not true. It's 3 or 7s. Because 3 can only be next to 8 and 9. 7 can only be next to 1 and 2. So if this is a 1, 7 has to be next to it. If this is a 9, 3 has to be next to it. So that leaves this as a 2-8 pair here. Okay. So this is satisfied. We don't know which way it goes, though. And these have to be alternating sets of digits. So we'll mark this as pink and this as yellow. Because on a Whisper 5 line, you'll always alternate between low and high digits on a Whisper 5 line. And this must satisfy the Whisper 5 line. So there's that. 27. So 27, you're guaranteed, can we ever have only four digits or less, or it would have to be 4 digits to add up to 27. So can we have only 4 digits adding up to 27, all satisfying the Whisper 5 requirements with the digit in front of it? I think the answer is no. So if we have to have 2 low digits. That's 3 and 4 at most, which is 7. So, and 2 digits are not adding up to 20. So therefore, or more. So therefore, 5 is guaranteed to be part of the set. The 5th digit. So this must be then pink, which makes this yellow. This is pink, and that's yellow. Okay. 20, on the other hand, you could have that. It could be just 4, right? Or it could be 3. You could have 3 between 8 and 9, and that would satisfy that. 34, can you ever have 5 digits? No. 4, 6, 7, 8, 9, 4 of them are high digits. So it has to be at least 6 digits, which means it has to be, obviously 5 could not be part of that set. So it has to be at least 6 digits. Can you have 3 digits with another 3 digits? That would be 3 low digits with 3 high digits. That would be 2, 3, 4 at maximum, plus 7, 8, 9. 2, 3, 4. 2, 3, 4 is 9. Plus 7, 8, 9 is 24. So no, you have to have 7 digits be maximal here. And you cannot have 6 unless you have 1 with it. Actually, that's not true. But the problem is 6, 7, 8, 9 already adds up to 30. So that means 30 plus at minimum 1, 2, and 3 adds up to 36. So that cannot work. So it must be the 4 low digits, 1, 2, 3, 4, which is 10, plus 7, 8, and 9, adding up to 34 here. So then this must be low, high. So these 4 digits are low. That means these 3 digits are high. And this is a 5, 6 pair remaining. Okay. So 4 has to be at one of the ends. So this is 1 through 4 here. This is 1 through 3 here. And 4 must be next to the 9. This is 1 through 3 here, 1 through 3 here. 1 could be here if this is 5. 7, 8, 9 here, 7, 8, 7, 8, 9. So one of these two is 9. We have to have 3 digits here at least, so this must be high, low, and high. At least. 4, can you have 3 digits? You could have 3 digits adding up to 18. So that's possible. This, we have only 4 digits here that add up to, because 5 is not possible here. So then this must be low, high, low, high. And this digit must be next to 2 unique digits that it has a whisper 5 relationship with. So this cannot be 4 here. Therefore, 4 has to be here, which is next to 9 on the whisper 5 for the whisper 5 value. So this is 9. This cannot be 9 here. These add up to 23. I think it has to be 3, 4, 8, and 9. That's the max, right? So 3, 4, 8, 9 is 7. Oh, that doesn't work. It has to be 4, 2, 8, 9. 3, 4, 8, 9 is 7, 8, 9, which is 24. We could only drop 1 digit, 1 value. If we drop, you can't drop the 4. That means the 3 or the 8 has to drop. And if we drop the 8, the 3 would have to be between the 7 and 9, which it can't be on a whisper 5 line. Therefore, the 3 must drop to a 2. So this is 2, which means this can't be 2. This can't be 2. One of these is guaranteed to be 3, which means it has to be, and this has to be 4 here, which means this is 9. So then 4, 9, 2, and 7 add up to 23, right? 9 plus 9. No. It's yeah, this has to be 4, sorry, 4, 9, 2, and 8, right? The 3 is dropping to the 2, but the 8 stays the same. So this digit is necessarily next to a 3 in this column. And to satisfy the whisper 5 provision, this must be 8, and this must be 7, which means this can't be 3 anymore. It's 1, which makes that 3 there. Okay. This can no longer be 3, 8, and 9. So therefore, this must satisfy that probability too. And we cannot have this be a high. Well, we could. But it cannot be part of the set adding up to 20. Because if that's the case, it would be at minimum 8, 9, and 6, which is 23 already. So this is not, these have to add up to 20 here. Cannot be 8 or 9, so we have 6 or 7 here. This can't be 3, it's 1 or 2. So we could have 6, 1, 9, 4 there. We could have 7, 1, 9, 3. Can we ever have 2 here? That would force us to be 7. So it'd be 7, 2, 9. Which would that's 18. Plus 2 would add up to 20. So that does not work. So this has to be a 1. So we're guaranteed this is a 1. One is here, which means this cannot be 1 here, so it has to be a 9. So the yellows have to be high, and the pinks have to be low. So this is 2. So we have 2 here. This is 8. This is 3, which means this can't be 3. That's 4. So this must be 6, 1, 8, 9, 4. No 3 here. It's 7, 1, 6. That makes us 4 and 9 there. This is low, and these add up to 27 without a 3. So this has to be a 1-2 pair here, because they are between 2 unique digits to satisfying the Whisper 5 solution. So this is 3 here. You cannot have 6 digits here, though, ever adding up to 27, because 16, well, no, 7, okay. This would be 1, 2 at minimum, 1, 2, 6, 7, 8, and 4. Well, we can't have a 4 here either. This 2 eliminates 2 here, so that's 1, which makes that 2. Okay, so that's that 2. So these 5 add up to 27. And so it's 27 minus 3, so this is a 7-9 pair here. That means the remaining digits, so where is the 6 in row 5? Cannot be here because it's 6 in the box, so 6 has to be here. That leaves the remaining digits as 4 and 5 in row 5. So 4 eliminates 4 here, so that's 5 and 4. That leaves the remaining digits in box 4 as a 2-7 pair. To add up to 18, can we have a 6 here? That would mean at minimum this is 6, 1, 2, 7. Well, okay. We can't have 6, 1, 2, 7. So minimums is 6, 1, 2, 7. What does that add up to? That adds up to 8? No, does it add up to 18? No, I don't think so. 30 has to have at least 5 digits here. So this is a high, which makes this low, high, low, and high. But it could technically be 30 for 5 digits, so that is potentially satisfactory. So what's the lowest for 4? What's the lowest sum for 4? We have 1, 2 is 3, plus 6 and 7 is 13. That's 16. So that's potentially possible. So we could have 4 here. We could have 3 digits. We are guaranteed one of these is a 1, though. And 1 cannot be here. So where's 1 in column? This has to then be one of these is a 1. In a Whisper 5 scenario, you always alternate between low and high digits. So since 1 is one of these must be low, which means this must be a high. And you cannot have 3 digits with a high. You cannot have 3 digits with 1 high digit to add up to 18. The minimum would be 3, 4, and 9. Or sorry, the maximum would be 3, 4, and 9, which adds up to only 16. So this must be all 4 of these satisfy the situation. So what are the possible combinations? 1, 2, 6, and 9? Yeah. So 1, 2, 6, and 9 is possible. We are guaranteed a 1 here. You could have 1, 3, 6, and 8. And there's no 4 possible. Okay. Where is 7 then in column 1? It cannot be here because of 7 in the box. Can't be here because of the German sum. So 7 has to be here. So this is 7, which makes this 2. Where is the 2 in column 1? It has to be here. So this must be 1, 2 next to 1, 9. And then plus 6, adding up to 18. That leaves the remaining digits as a 3, 8 pair in column 1. In box 1, it has to be 3, 7, and 8. No 7 here because of 7 in the row. That leaves the remaining digits in column 2 as 5 and 6. Okay. This scenario could be 2 digits, could be 3 digits. Cannot be 4 because 4 digits at minimum would have to have 2 lows and 2 highs. But that doesn't really help us much. But basically, it cannot be. It's either 3 digits here adding up to 12 or 2 digits. We don't know which. So this is satisfied, this is satisfied, this is satisfied, and this is satisfied. This is satisfied. We don't know about this. This we have to figure out. So this has to be 6 or 7, which means this is 1 or 2 next to it. This is 6, 7, or 8. Can't be 6 because it's next to 2 unique digits on the that has to satisfy the whisper 5 line with. Therefore, what is this digit? It can't be 2, it can't be 3, and it's next to 2 unique digits satisfying the whisper 5 proviso. So this has to be 1. So that makes this 2. Therefore, that's 3 here. 3 plus at most 24 is only 27. So this must satisfy that proviso. So this must be a 3 here. Can we have a high digit? No, because then this would be 4 high digits here, which already add up to 30. So then this must be 7, 8, 9 here to add up to 30 for the 6 digits. So this is 7, that's 8, that's 9, which makes that 7. Remaining digits in column 6 eliminates 6 here, so that's 5, which makes that 6. We have 4, 5, and 6 only remaining in column 7. This can't be 5 or 6, it's 4. This can't be 4 or 6 because of 4 in the column and 6 in the row. So it's 5, which makes that 6. Okay. This is either 2 digits or 3 digits adding up to 11. If this is 2 digits adding up to 11, it cannot be 4, 8. It has to be 5 apart from each other, so it must be 3, 9. We are guaranteed a 9 here, actually. So it could be 3, 9, because there's no other place for 9 in row 8, because these are 9 here and 9 here. Or it could be 1, 2, 9. But where is the 1 in row 9? Can't be here because of 1 in the column, so we're guaranteed a 1 here. So this has to be a 3, 9 pair here, adding up to 12, because we no longer have 1, 9, and 2 possible to add up to 12 here for these 3 digits. So 3 cannot be here. Where is the 3 in row 9? It has to be here. So that's 3 there. This can't be 3 because of the 3, 9 pair in the row, so that's 8 and 3 there. Also, we had an 8 there, which eliminated that possibility. Remaining digits in row 9 are 1 and 6. Remaining digits in this box 9 have to be 4 and 5. That eliminates 4 and 5 in the rest of the row. So no 5 here. That's 6, which makes that 5. We have 1 and 6 remaining in row 8. This can't be 1 because of 1 in the column, so this is 6 and 1 there. That leaves 2 and 7 remaining in row 7. Okay. Where is 7 in row 4? It cannot be here because of 7 in the box and the rest is filled. So this must be 7 here, which means this can't be 7. That's 2, which makes that 7 there. Remaining digits in row 4 are 5 and 8. Remaining digits in box 6 are 4 and 6. Remaining digits in box 5 are 5 and 9. Okay. 1 can only be next to 6 can only be next to 1 on a whisper 5 scenario. So this is 1, that's 2. Remaining digits in column 4, we have 2, 3, 5, and 9. So no 5 here, no 5 here, no 9 here, no 2 here because of digits in the rows. Remaining digits in column, well, where is the 4? 4 can't be here, 4 can't be here. So 4 has to be here in column 6. which leaves the remaining digits as 5, 8, and 9. Okay. 5 can't be here because of 5 in the row. Remaining digits in row 2. We have 2, 3, 7, and 8. 2 can't be here because of 2 in the column. 7 can't be here because of 7 in the column. You could have 2 digits here if it's a 3, 8 pair, or 2 and 9. Oh, this cannot be 9 here. If this is 3 and 9, then this would satisfy 3, 9, and 2, which satisfy the Whisper 5 proviso. So this cannot be 9. Therefore, this is 3, which makes this 9. Because 5 away from 3 is not 2. This can't be 8 for the same... Well, no, hold up. Never mind. There's no proviso there. Never mind. This is 3 and 9 here. Therefore, this cannot be 2 and 9 to add up to 11. We don't have 7 available. 6 and 1... Okay, so 3 and 8 work still. What other scenario could we have? 1, 2, and 8 to add up to 11. 1, 3, and 7. 7 cannot be 5 or more away from 3, so that doesn't work. So yeah, 8 is guaranteed to be either here or here. That eliminates 8 from being here, so this is 5 and 8. 5 eliminates 5 here, so it's 4 and 5. 4 eliminates 4 here, so it's 6 and 4. 6 eliminates 6 here, so it's 1 and 6. That means the remaining digit, this can't be 3 or 8 because of 3 or 8 in the column, so it's 7. No 7 here. And therefore, the adding up to 11, it must be 3 and 8, which means this has to be 2. But again, we cannot have this be 5 away from the 2, because then the 2 would satisfy the Whisper 5 proviso. So this must be 3, and that must be 8. 8 eliminates 8 here, so it's 9. 3 eliminates 3 here, so it's 2. 9 eliminates 9 here, so it's 3. No 3 or 8 here, so that's 7. 3 eliminates 3 here, so it's 8 and 3. No 2, 3, or 9 here, so it's 5, which makes that 8. That leaves this as a 1 and this as a 9. 5 eliminates 5 here, so it's 9 and 5. Very cool, actually. I really enjoyed the German sums. That was a very interesting... It's an intriguing rule set, right? And it already takes advantage of the Whisper 5 rule set, which we have in place, and just sort of extends it on what it can be used for. So, very cool. Very nice, and a good introduction, too. It flowed very well throughout, and it was a very nice setting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.